Well, all that stuff about inequalities in the previous section of your textbook is leading us now to absolute value inequalities, which have some purpose and usefulness in mathematics. We run into this, for example, we actually use these in our Calculus 3 class, is one that comes to mind. And so I realize not everybody watching this video is going to go on and take that much math, but that's beside the point. The purpose of college algebra is to prepare you for calculus, whether you plan to take it or not. So it's on the path toward that subject, and so it prepares you for it. All right, so let's start with a simple case, and I'm going to focus on less than and less than or equal to in this little video. If you look at the absolute value of x and say, well, let's make this less than or equal to 6. Okay, what would that mean? Well, by now, hopefully you've got it in your head, the absolute value is measuring distance from a point on the number line. And I'm turning these into distances from 0, because I think that's an easier way of looking at it. So this describes all the points which are less than or equal to a distance of 6 from 0. So on a number line, where would that be? And so if you go out as far as 6 units from 0, that takes you to 6. It also takes you to -6. So I travel 6 units either direction. I go out to 6, but this reads less than or equal to. So we're going to include the 6, but consider also everything that's less than a distance of 6 from 0. Well, that takes you inside this interval. Everything inside that interval is less than or equal to 6 units away from 0. It's within 6 units of 0. So this means that our inside here, x, falls inside that interval. Well, that sets up an inequality that says that x lies between -6 and 6. And in interval notation, which is what I'm going to expect from you, x belongs to the interval bracket -6 comma 6 close bracket. And we're done. So here's the interval notation describing all the answers to this problem. Well, let's make it a little more complicated, and I'll erase this and give you a little more complicated problem. Here's our next problem, and I just noticed looking at my my computer over there that this looks really slanted, even though the camera is pretty level, and so I don't know why that is. It doesn't look quite that bad to me. I mean, maybe it does if I step back from it, but oh well. I'm just handwriting on the board, freehanding it, so I'm going to be slanted once in a while just because I'm me. Solve absolute value 3x plus 4 less than 5. Graph the solution on a number line and write it in interval notation. So I'm not going to hand write that direction on all these problems, but I will expect it in the homework and on the test if you're my student, and I will handwrite it or give it verbally if you're in a regular class of mine. Alright, so graph the solution and write an interval notation. I like you to do that because I want to make sure that you know how to represent this answer accurately, and so you can tell exactly what it means. I think that's fair enough. Alright, so what's this describe? This describes the points which are within 5 units of 0 on the number line. And so here we're not including 5, we're not including the endpoints, so that sets up an open interval between -5 and 5, and 3x plus 4 is what lives inside that interval. So we're looking for all the x's that make this true. Well, that means that this is sandwiched between -5 and 5, so that sets up a compound inequality like before. And how do you solve these? I know I haven't solved one of these yet on the video. Well, a compound inequality is really, of this type, is really two separate inequalities combined into one. And so it's like we're working two problems here. Well, we can work them simultaneously, at the same time. And if you think, well, how are you going to solve for x? Would you just subtract 4 from every part? Good news is yes, it's quite intuitive that way. So I want to isolate x. First thing I'm going to do is subtract 4 from each of the 3 parts. So this gives me negative 9 is less than 3x, and that's less than 1. And now I'm going to divide by positive 3, and because I'm dividing by a positive number, it doesn't change the inequality symbols. So I end up with negative 3 is less than x, and that's less than 1/3. Okay, so, and again, ordinarily I would write down below, but I'm out of board space, so I am going to need to erase in order to write the answer this way, as I've asked for. Okay, well, here we have our inequality. So on the number line, that describes numbers between -3 and positive 1/3. And please make sure that you put these in the right order. You always have the less than number to the left of the greater than number. And it's fairly obvious between -3 and 1/3, but when you get fractions of the same sign, it may not be quite so obvious, but I want you to be careful about that, because on the number line, to do it correctly, the number on the left has to be less than the number on the right. So don't overlook that fact. All right, now this is an open interval between these two numbers. And one thing I want to point out is that when we started to interpret this problem, I had an open interval. And there's nothing about this problem that's going to change that. If you start with an open interval, then you're going to end up with an open interval for an answer. This will not change. And okay, as far as interval notation, x would belong to parentheses, -3, comma, 1/3, close parentheses. So there we go. That describes all the numbers which will fit into this inequality. I want to work one more, and this time in the course of solving, we'll be dividing by a negative number, and so I want you to see one of those examples as well. Here's an example. Solve absolute value 11 minus 7x less than or equal to 5. Okay, so again, this is going to describe a set of numbers within this distance of 0. And I have 5 up there, so we'll put 5 and -5 on the number line. And we're including equal to 5. So up to 5 units, including 5 units, either direction of 0, causes this to be a closed interval. So I'll write it there. Notice how I'm drawing the interval of the problem. And 11 minus 7x is what appears inside this interval. And to expand on a comment I made a minute ago, the answer to this problem, as long as that was correct, the answer to the problem will be another closed interval like this. That cannot change with a linear inequality. So, if you end up with a split interval or just starting here and going all the way to the right, for example, that's going to give you a bad answer. All right, so I'm going to sandwich 11 minus 7x between these two numbers. Gives me -5 is less than or equal to 11 minus 7x, which is less than or equal to 5. So again, with this kind of, and I call this a sandwich inequality, we can actually, we're really solving two separate inequalities at one time. I'm going to subtract 11 from all 3 parts. That gives me -16, less than or equal to -7x, less than or equal to 5 minus 11 is -6. And now I'm going to divide by -7 to finish. And that should raise the alarm bells, because when you divide by a negative, what happens? You have to change the inequality symbols. So this is going to give us, and I'm going to erase this so I can write above here. This is going to give us, and here the negatives cancel, so 16/7 is greater than or equal to x, which is greater than or equal to positive 6/7. Now, if you forgot to switch these inequality symbols in solving, if those were less than or equal to, then in essence you would have 16/7 is less than 6/7. And that's not true, is it? Because this string of numbers, if you do it correctly, the string of symbols says that 16/7 is greater than 6/7, which is true. Now, I like to organize this answer so that the small numbers on the left and large numbers on the right, in terms of less than or greater than. So I'm going to rewrite this and put 6/7 is less than or equal to x, which is less than or equal to 16/7. So notice that when you do that, swap the sides. That's the other reason we change inequality symbols, is if you swap sides. Now it's in the correct order and it runs from left to right. Smaller number less than or equal to x, less than or equal to a larger number. And I'm going to now finish it. Draw it on the number line. All right, we'll draw the number line, and 6/7 and 16/7. Well, there's 6/7. There is 16/7. And oh, it's kind of nice to put arrows there. And again, I'm not a stickler for you putting a bunch of numbers on a scale, but do make sure that if this number is on the left, that is smaller than the number on the right. You know, that's mandatory. There's no way around that, because that's the way we organize our number line. All right, now we're including the endpoints, so I'll color in the circles, shade in between, and like I said a minute ago, you know, our answer, which is a closed interval, duplicates the original problem I set up, which was a closed interval. All right, so finally the interval notation: x belongs to bracket 6/7, comma 16/7, close bracket. And now we're done with these.